Okay, let's go through the first set of multiple choice questions. Never mind, it's okay. Understand, alright. Okay, which of the following is used? So we're going from the right to the left, right? Because of the printing, so we follow the number sequence. Which of the following is used to measure volume of liquid most accurately? We're talking about most accurately. Anybody?
Is it bigger?
The beaker? No.
Huh?
The answer is the C, burette.
What was that?
Burette, do you know what's burette? Oh no. Okay, burette is an apparatus that looks like a really long test tube, super long test tube with a lot of markings on the side. Okay, that's a burette. So burette is the most accurate. Now beaker is just one beaker like that. What's the reading on the beaker? 150 only what? How can it be the most accurate? Okay, 150, so cannot be. Conical flask, looks like that. Doesn't even have any reading. Right? Boiling tube also don't have. Okay, so the best is the burette. Next. Chemicals once removed should not be poured back. Why? Because C, yeah, they may be contaminated. You cannot pour it back in. If not, you will contaminate the original chemical. Okay, 3. Why should the Bunsen burner be left with a luminous flame be left unattended? Luminous
Or is
flame.
it A? D.
No, it's not A. Yes, it's D. Because you can see a luminous flame easily. Luminous is which color? Blue or orange?
Orange.
Orange. So blue you cannot see.
Why?
Well, according to their theory, right? When it's blue in color, it is a bit invisible, right? So you should always change it to orange so you can see. So the answer is D. Okay, next one, 4. We have a Bunsen burner. Which part should be used to heat the bottom the fastest because of the fastest heating? Is it A, B, C or D?
C.
C, yeah. You can use C. C, yeah. Right. Next one. Question 5, right? Which of the following can be separated using a separating funnel? The answer is B. Oil and water. Okay, separating funnel is not filter funnel, so there's a difference. Separating funnel. What's a separating funnel? Ever seen a separating funnel before?
Yo.
Ever seen a separating funnel? Hello.
No.
No? Okay. Come, Rian.
I'm not late.
You're not late?
Yes, I'm not late.
Then what is the time now? It's almost 5. What did you say? You said that you're late. Yeah.
Yeah, my science paper was okay.
That's good.
A
Good to
lot
hear.
of density questions.
Good to know that. Okay, but we're still doing revision because our friend Jaka is still having exams. Okay, so we shall all revise. But it's okay. So next week, as I was saying, next week we'll do a brand new topic. Right. Okay, question number 5. The answer is 2. Because separating funnel is not filter funnel, it's different. Separating funnel looks like a burette. It's just one long stick where it's used to separate oil and water. Why? Because the oil will float at the top. Let me show you. The oil will float at the top. Here will be oil, and then water will be at the bottom. So the separating funnel has got a tab. Separating funnel got a tab.
Oh shit.
What you do is you open and close the tab.
Oh my god, I drew it wrongly.
Huh? What?
I drew it wrongly for my chemistry.
Never mind. You open the tab so the water will come out. Once all the water come out, and you make sure that the oil will come down, and then just close. Okay, that's the separating funnel. Next. Salt crystals are found on the shore of the Dead Sea because of
I don't know.
A. Evaporation. Evaporation. The Dead Sea. What is so special about the Dead Sea?
You can float in the sea.
Why you can float in the sea?
Because the water is very salty.
And so what if it's very salty? How come you can
The
float?
buoyancy.
What? Okay, according to science, you study density, right? How come you can float?
Oh, the density is low.
Yeah, the density is lower than the
Water.
sea, than the water.
Underground.
How come? Then how come the Dead Sea density is so low? Alright, how come the Dead Sea density is so high?
What's the difference between Dead Sea and sea?
Oh my god.
So
Need
it's
to
like
go and
Dead
see the
Sea,
Dead
right? If you lie,
Sea.
oh yeah, you're not Chinese, that's why. Because in the Chinese textbook we must say.
Huh?
It's like right in the Dead Sea,
Okay,
right?
we must
you can like
see.
float in the water.
Yes, let's go see Dead Sea. Dead Sea.
But you may somehow choke in the water as well.
Dead Sea. Okay, see what's he doing? What's he doing? Reading newspaper while with his leg up here. Okay? Why? Why he can float? How come he can float? Because the water is very salty. Now when it's very salty, so what if it's salty? Huh? Yeah, high density. So the water has very high density. So he naturally become low density. So when you jump in, you're like very low density, what so you float?
How do they just swim?
Swim? No, you swim, just float lah. Just float. Is it?
They
You
say
see so much salt.
There's no fish there because
It's too salty. They open their mouth, they become salted fish. Alright, so this is the salt. Okay, salt crystals. Why is the Dead Sea so salty? Yes, because there's so much salt inside there. Can you? Where? Somewhere near Israel, I think. You can actually go there and holiday, right? You see, holiday. See, oh, you see this?
Wait, I thought if you're denser than something, then you will sink in.
You're less dense because the water is denser than you.
So if the water is denser than you, it means the water is. Oh, okay, I understand.
Right, the water becomes denser. So just now you were asking about
So
the.
what about the evaporation? Like, how does the evaporation work?
No, evaporation occurs because of they're asking how come got so much salt crystals.
So the
How come
salt
you
from
see
the
so
sea
much?
evaporate.
No, the salt don't evaporate. The water evaporates, so left the salt.
Or they condense with the air.
Don't need to condense. They just ask how come got so many salt. How come got so much salt? Because water evaporates.
I buy water.
What?
I buy water.
Got water cooler.
That's salt water.
This one. Okay, easy.
How did salt get its name?
How did salt get its name? Wait. Which type of salt are you talking about? Because in
Caramel.
science, there are two types of salt. One is called table salt. It's the one that you eat, the one they put in French fries. That's called table salt. Then the other salt is actually the
Word salt.
no, it's actually the chemistry salt.
Sodium.
It's compound. Sodium chloride. No. Sodium chloride is table salt. There's another salt. In general, compounds are called salt. Okay. Now I want to see filter funnel. Okay. Separating funnel. There. Okay, this is a separating funnel. Okay, so how do you remove oil and water? So oil will be at the top, low density. Water is at the bottom. So you open, close a bit. The water will come down. That's it. Okay, what else were we looking at just now? That's all right. Oh, the burette, is it? What's the burette? Burette looks like this. Burette. With a lot of markings. It's a burette. There's a lot of markings along the length of the thing, so it's more accurate than the beaker or any other instrument. Alright? Okay, let's continue. Right? Which of following show that water is pure?
Freezes at 0 degrees.
Yeah, very good. Right? D. Because if it's not pure, it's impure, it will be over a range of temperature. So answer 7 is D. Next one, to separate a mixture of sand and salt, the first step is to stir in some water. What are the next two steps?
Is it C?
Wait, stir some water, evaporate, then filter. B, filter then evaporate. When you filter, you remove the sand. You filter, remove the sand. And then what comes out, right, is the salt water. Then you evaporate. The water gone, left with salt.
So answer is
D.
D.
Yeah. D. Okay, next one. Okay, fractional distillation. Who learned this? Who haven't learned this? Fractional distillation.
Only distillation.
Distillation, you learned this.
How does it work? Okay.
Okay, must see picture.
I haven't learned that.
Fractional distillation. Read picture. Okay. So the difference between distillation and fractional distillation is that fractional distillation have this. They have this thing. Normal distillation only have this. Without this. Okay. Now, so which one is better? Fractional distillation is better because the liquid going up has to go through more rounds of condensation, evaporation. Means whatever comes out here is more pure. Fractional distillation, whatever comes out here is more pure than normal distillation. Normal distillation don't have this thing. Imagine don't have this thing. So it's just like that. Okay, now what's the purpose of distillation? Imagine you have oil and you have ethanol and water inside here. Ethanol and water. Ethanol basically is like alcohol. So how do you separate alcohol and water? You put them in the distillation the distillating setup like that. You burn this thing, the alcohol will evaporate first. Any question?
Then what's that thing there?
Where? This one?
Yeah.
This one. This is called the condenser. Because once the alcohol evaporates, very hot, right? And then when it comes into here, it will condense, become liquid. As it becomes liquid, it will drop back inside. So that's why you also need water in, water out. The water in goes in to cool down the hot water or alcohol.
Then what's the water out thing?
Water out means water go out.
Also, you go in then go out.
Yeah, go in from bottom, go out from the top.
Oh.
Yeah. Okay. Going from bottom, go out from the top. Next. So this is fractional distillation. So you want to obtain pure nitrogen and pure oxygen from the air by first cooling it. So this method works because they have different boiling point. Okay, the answer is A. Different boiling point. Next. 10. Drinkable water can be obtained by
What question?
10.
Huh?
Next page. Drinkable water can be obtained by distillation, yes. Evaporation, no. Reverse osmosis, yes. So it's 1 and 3. Answer is D.
What's 3? What's 3?
3.
Yeah.
Reverse osmosis. Oh, do you go to the
No.
Singapore water barrage, Marina Barrage?
Yeah, last year.
Yeah, they use reverse osmosis.
And they just show us the water. I didn't like really listen.
Okay, so Singapore use reverse osmosis. Distillation is just now the setup that you saw. What's reverse osmosis? Okay, let's take a look. Reverse osmosis. See, this is so nice, huh? Okay, what is osmosis? Have you learned osmosis? Huh? Learn the water molecules, right? So reverse osmosis, basically you take a look at this diagram. You take salt water, okay, you add pressure, then the water is being pushed through some kind of a membrane. Membrane is like a filter, right? The water is forced through this part. So it goes here. Water goes through this membrane. It's like filtration. Filtration. Like that. Okay, so Singapore does this. Reverse osmosis. Where? At the Marina Barrage. You know what's the Marina Barrage? Huh? You don't know? Can you not know? Marina Barrage. Singapore. This one. This one. Marina Barrage. Open to public one, no? Free, you can go. Right? It's over here. This is a flyer, this is a Marina Barrage, right? They built this thing, so this becomes another reservoir. Right? So we have, how many reservoirs do we have in Singapore?
那个本土人生
How many? How many? 3? How many?
I don't know.
You don't know? Guess.
4.
4? 5? 1? 17.
Huh?
We have 17 reservoirs. You only know Bedok Reservoir. Okay, we have a total of 17 reservoirs.
Yeah, not so big, man.
No, that's why we are not so big, so that's why we need more reservoir to store water. If not, we will not have enough water. Okay, next. Elements in the same row show a gradual change in physical property from left to right. Yeah, very good. Metal to non-metal. Good. During the melting process, what happens to the water molecules?
B.
B. B. Yeah, they gain energy. Very good. Next one. 13.
C.
C. Process 1, melting. 2, evaporation. 2 is not evaporation. What?
Huh?
Water to steam.
B.
Wait. Freezing. Okay. Wait, 3 is condensation. The answer is C. The best answer is C. Because process 2 should be boiling, but they use evaporation so can. Because it's from liquid to gas. Right, that's fine. Okay, next 14. Glucose is C6H12O6.
It's not periodic.
Which elements? B. Carbon, hydrogen, oxygen. That's correct. No need periodic table. C, H, and O you must memorize. C is carbon, H is hydrogen.
About 15 need periodic table.
15. Which of the following is a non-metal? D. Sulfur. What is sulfur?
Really, man?
Yeah?
I thought it's a metal.
What? Wait, do you know what is sulfur?
Yeah, I know.
Where do you get sulfur from?
I don't know.
Iron.
Sulfur.
I don't know where I like.
Where do sulfurs come from? You see this? Underground volcano. It's a powder. Sulfur powder volcano. Acid. No, yeah. Acid rain, you know? Acid rain. Because got sulfur go into. If you study geography, right? You study volcano. When they erupt, sometimes a lot of the sulfur comes out. They go into the rain, mix with the water, come down, become acid rain. Sulfuric acid. Okay. If you have been to Taiwan, so they have this. You can go to this place beside a volcano and you can bathe in the acid the sulfur water.
Is it acidic?
Yeah, it's a bit acidic, but it's sulfur. You come out in all yellow color. Sulfur. Why?
The rain is yellow color.
No, the water, because it kills bacteria. Sulfur kills bacteria. Now,
So do you swim in that?
Yeah, the whole place is sulfur. So if you are in NCC, NPCC, Scouts, Girl Guides, Brownies,
Okay, I'm very glad that I did join this.
you go to camping, they will give you 1 packet of sulfur. Why? When you go camping, they give 1 packet, this one, yellow color sulfur. Why? Because at night, you must scatter around your tent.
Do what?
How come? Why must scatter around your tent?
So that the mosquito
Snake will not come.
or snake.
Snake inside all this, they smell sulfur, they'll be like, oh, volcano, they'll run away.
What if the snake dropped from the tree?
Then he will also run away.
How?
Then he will run inside the circle. So you must.
Why not inside
What is sulfur?
the tents?
What?
Why not inside the tents?
Put sulfur in the tent, then you die. Sulfur is poisonous, you cannot like eat or smell too much.
What if like sulfur, like the cell touches skin?
Nothing will happen. But if it is too much, then it's bad. Highly concentrated is bad. A bit is okay. A bit is fine, right?
Wait, what if the snake touches it?
What is the what?
Snake.
The snake touch the sulfur? Nothing. No. They will just smell the thing and then they will think that there's a disaster coming and then they will just go away. Okay, that's the sulfur, right? Very interesting element, right? Okay, so sulfur is not a metal, so it's a non-metal. Okay, next one. Oh, okay, let's back to this question. So name the apparatus labeled A, B, and C. A is a flask.
Bottom.
Round bottom. Where got round bottom? It's not round bottom.
It is.
Round bottom is round, no? Like round.
Oh,
It's not. Flat bottom flask. Okay?
but still round.
It's a flat bottom flask. Okay? B, conical flask. C, oh no, where is C? C is the. Where is C? I think C is the gas jar. C should be pointing to the gas jar. Okay, what's the type of flame used and how it can be obtained? Now over here, it needs to be strongly heated. Strongly heated. So what type of flame? Is it the luminous or non-luminous?
Non-luminous.
Yeah, non-luminous because you need high heat. Okay, how is it obtained?
By a mountain.
Open or close the air hole?
Open.
Open the air hole. Okay, so you open the air hole and you can obtain a non-luminous flame which is very hot. Next. Okay, you have hydrochloric acid. What should the student do immediately if the acid is spilled on him?
Spill on him like that.
Yeah.
Touch his skin.
Yeah, touch
Wash
his skin.
up.
Yeah,
Wash his
wash
hand.
with a lot of water, right? Right. Don't play around with acid. It's really dangerous. Next. Okay, what is this method of purification?
Distillation.
Yeah, very good. Distillation. Suggest the purpose of the water jacket, which is the
So it's called
condenser.
water jacket.
No, there are many names, right? First name is condenser, next one water jacket, there's another name called the Liebig condenser. So they all serve the same purpose, that is to cool down the steam. Whatever evaporates, they want to cool it down so that it can condense. So the purpose of the water jacket is to condense the gas or the liquid, sorry, is to condense the gas or the steam so that it can become liquid. That's the purpose of the water jacket. We call it water jacket here so that you don't know that it's a condenser, right? So what's the reading on the thermometer during the purification? What's the boiling point of water?
100.
Yeah, so it'll be 100 degrees Celsius. Because that's where the water will evaporate. Okay, at 100 degrees Celsius it evaporates. Draw a cross where the copper sulfate will be left after purification is complete. It will be left at the bottom here. Copper sulfate. Okay, it will be left at the bottom. Next. Another student accidentally spilled alcohol. The above seller is not suitable to remove. Suggest a suitable separation method. So if you have alcohol inside, how? What's another separation method?
Filtration.
No, use the.
Vapor chromatography.
No, just now we saw.
Crystallization.
No, we saw it just now.
Evaporation.
No,
Filtration.
no,
Distillation.
no. This distillation already. Which one is better than distillation?
Evaporation.
Fractional distillation.
Oh.
Yeah. Okay, use fractional distillation. Explain why the method you suggested is more suitable because you have the fractionating column, the one at the top that will be able to distill it better or properly. Okay? Next. Oh man, one column missing. Okay, there's a column missing, I can't really tell. Okay, I can't tell. I can't tell what it is, but I can guess. Okay, now element W, I think it's mercury because it's silvery, melting point -39, and used in the thermometer. Right, W is mercury. Next one, physical property of X.
It has a high melting point.
Yeah, high melting, high boiling point. From the table, which element exists as solid? 25 degrees Celsius.
Is it Z?
Solid Z? No, it's a gas, you know. Z is a gas at 25. There are two, right? X and Y. Because their melting is 1000. So at 25 is definitely a solid. Next. Right? Okay, why a liquid takes the shape of a container but a solid does not? Hmm? Different shape? Okay. Because liquid does not have a definite shape, but you must use kinetic particle theory.
The particles
Are
not in fixed position.
Yeah, they're not in fixed position and they are sliding against one another. Okay, so who learned kinetic particle theory? Who learned? No? No? Are you awake? Are you still sleeping? Have you had lunch? No? No food? Okay. Oh, you haven't learned, right? Kinetic particle theory. Okay. Alright, so it's because they are sliding against one another and it does not have a definite shape. Okay, a gas is easier to compress than a liquid because there are a lot of space in between the particles. There are a lot of space in between the particles. No more. Just not a physics student ate everything. Right? This Kara looking at you like, what's going on with this girl? It's like that, huh? She's been like this since last year. Right? Yeah, here is always food. Every time I ask for food. Okay, so a gas is easier to compress because there's a lot of space in between, okay? Got a lot of space in between. Now, how does it look like? Let me show you. Kinetic particle theory. Kinetic particles theory. What's it slow? Gas particles. Okay, it's not working. Jump back. Right? So I have to draw. Gas particles are far apart. Like gases. Oh my god. The particles are far apart. So in between there's a lot of space. There's a lot of space in between. So therefore they can be compressed. Okay, gaseous particles are far apart, so that's why it's easier to compress. Next, we have a heating curve from 0 to 105. Complete the table. What's point A to B? Point A to B, this is water, right? So at 100 degrees Celsius, this has got to be liquid. A to B is liquid. B to C,
Liquid gas.
plus gas. And then C to D,
Gas.
gas. Okay, gaseous state. Right, this is under chemistry, kinetic particle theory. Which is not too difficult. Okay, describe a motion arrangement of particles at -2 degrees Celsius. Where is -2? -2. Okay, so water at -2 degrees Celsius, is it solid, liquid, or gas? Liquid at -2. Come on, liquid at -2. Yeah, it's a solid. So what's the motion? They vibrate about
fixed position.
Yeah, about fixed position. This is something you learn in kinetic particle theory. Okay, the arrangement. What's the arrangement of solid particles?
Neatly arranged.
Yeah. So orderly arrangement, they look like that. Closely packed. Okay, they're all closely packed. So the arrangement is orderly arrangement. Okay, what's meant by iodine sublimes at 184? You know?
Sublimation is solid gas, right?
Yes. Okay. So iodine changes from solid to gaseous state at 184 degrees Celsius. Okay, iodine changes from solid to gaseous state. That's the meaning of sublime. Next one. Okay, what's the similarity between Q and T?
They are elements.
Yeah, it's made of one element. They are made of one element. One type of element. Which diagram represents molecules of compound?
P and S.
P and S, yeah. P, S. Okay, which one is a mixture? R, yeah. Very good. Water?
P.
P, yeah.
Really? But water is a compound, right?
Yeah, but they're asking about water. H2O.
Wait, you know the thing, right, about water, right, is they say that what a compound cannot be broken down by physical methods, right?
Yeah.
But then water can be broken down by electrolysis, right?
Yeah, it's not a physical method. Electrolysis is a chemical method. Chemistry, right? Chemical method. Okay, next. Janelle was given 2 samples. Classify the 2 samples as element, compound, or mixture. A is a salt solution.
So it's a,
B is salt with chemical formula as NaCl.
what's Na?
Sodium chloride. So B is a compound. B is a compound. How about A?
Mixture.
Mixture, good.
So it's salt and water, salt will dissolve,
Yeah, so it's a mixture.
but it's chemical combined.
Chemical must have burning, must be electricity. Okay, or there is some type of a change. That means a chemical change in the compound. Right, when you mix salt and water, there's no chemical change, it's just dissolving. Okay, next, what's the difference between sample based on 1? Compare 2 different samples. Okay, you need to remember the difference.
Oh, I know, the mixture has the properties of the
Very
substance
good.
it is made up
Very
of.
good. Mixture has the properties. Its components. One more.
A compound is
Mixture is physically
a
combined.
mixture can be broken down by physical method.
Yeah. A compound.
Can
A mixture can be broken down.
A mixture can be broken down by physical method.
Yeah,
but a
compound is
cannot be
chemical.
broken down.
Yeah.
Used to be.
Yeah, you 会学得懂 right? 学得懂，有些东西 you like to know boys.
She's very annoying. Not very annoying. She always like spread rumors about me.
Yeah, he said and don't worry. She kicked someone in the butt in our school.
In what?
In SJC. In the class.
She told me she asked like, do you know how to answer now? So from the tuition.
Okay, let's continue. Okay, so you got the other one, right? The other difference. Right, simple, straightforward. Next. Oops. Last one. Okay, this is the paper chromatography. What is the method used? It's called chromatography.
I don't know how it works.
Are you tested?
I think so.
Okay. Okay, which ink is a pure substance? E. Right? Why? Because there's only one dot. If it's not pure, there will be many dots. You see? 1 dot, 2 dot, that means not pure. So E is the pure substance. Now how does it work? What we do is you dot the starting line. You see, you put the ink at the starting line. Let's say C.
But D also only got one dot.
Ah?
D also.
Okay, D cannot. You know why? Because it cannot dissolve.
Oh.
Right? So let's say, now what happens is that when you put at the starting line, let's say C, let's use C as an example, the water is submerged until this point. You submerge the whole thing into water. So water will go upwards. As it's going up, it's actually being, it's like the C will dissolve into the liquid. So the one that's at the top is actually the most soluble, whereas the one at the bottom is the less soluble one. Why? You can imagine the water carrying C. Imagine water carrying C upwards.
Yeah.
And then the less soluble one will be deposited at the bottom. The more soluble will only get out of the liquid at the top. Okay, so how come E is pure? Because there's only one thing in E. There's only one thing. It's not separated into many things. Why? Yes? Understand?
Yeah.
Okay, can. So which two ink can be combined to make A? So you have to look horizontally, C, and then this one, E. So C plus E. Okay, do you understand? C and E? Because A consists of 3 dots, so you need you need 3 dots to make A, so you get C and E. Why D remain on the starting line?
Because it's insoluble.
Yeah, it is insoluble in the solvent. Oops. In the solvent used. Very easy paper. No. Okay, do the next one. I go and find, okay? Here you go.
Bye.
Oh, you want to go? Go. I gave you already, right? Huh? Don't have. I think don't have.
You think correct?
Yeah, actually I'm quite